Hi, good day everyone. This video is about solving rational equations. Again, to solve rational equations, we only have these three simple steps. Number one, we need to eliminate the rational expression in the equation by multiplying both sides of the equation by the LCD. Step number two, we need to solve the equation or solve for the values of x or any variable given. And next or last is to check our solution. Now, let's try to answer some set of problems. Let's say we are asked to solve for the value of x if we have x over 5 plus 1 over 4 is equals to x over 2. Okay? So again, our first task here is to identify what will be the value of our LCD. So for our LCD, our technique here is just observe the values of our denominator. So since to our case we have 5, 4, and 2, again we need to think of a value, okay, wherein 5, 4, and 2 will serve as the factors of it. Okay, so I guess the value for this one that is equals to 20. So let's try to double check. So if we have this LCD as 20, so 20 is divisible by 5, yes. It is also divisible by 4, and it is also divisible by 2. That means we have this correct value of our LCD. Okay, so let's multiply that LCD to each term, okay, of our given rational expression. That means it will give us 20. Okay, 20 times x over 5 plus 1 over 4, and that is equals to x over 2. And again, multiply it both sides of our rational expression. And after that, just apply the distributive property of multiplication. So distribute the values of this LCD. So 20 times x, it will give us 20x over 5. Next is 20 times 1, will give us 20. So that is plus 20 over 4. And that is equals to the right hand side, we have 20 times x, which is 20x over 2. Okay. After that, let's simplify. And after this step, we will eliminate our denominators. So simplify this one. Therefore, it will give us 20 divided by 5. That is equals to 4x. Okay, so we have 4x. 20 divided by 4. That is 5. So plus 5. And that is equals to 10x. Okay, so 20 divided by 2 is 10. And copy the variable x. Now, after this step, since we eliminate our denominator, so we have this linear form of expression. So let's try to solve the value of x. Okay, let's isolate the value of x and simplify it. So I think we need to remove 4x. Okay, negative 4x both sides to isolate the value of x. So therefore, it will give us cancel out this one. Therefore, it will give us 5 is equals to 10x minus 4x. Alright, so some of you guys, you are allowed to maybe some of your technique is to move the value of 4x with use of transposition, so it's up to you. But again, our goal here is to isolate the value of x or solve for the value of x. Since we have this given expression, we have 10x minus 4x, 10 minus 4, that is equals to 6x, and we have equals to 5. And next, we need to divide this both sides since we're looking for a single value of x. So divide this both sides to 6. So it will allow us to cancel out 6. Therefore, the value of x is equals to 5 over 6. Okay, that is our answer. Now, if you want to double check your answer, since we have this given rational expression or equation, we need to substitute our solution, okay, to our original expression. Okay, if it satisfies our rational equation, therefore, our solution is a real solution. Alright, so let's try to double check. Let's do some checking. Right, so for checking, we will use 5 over 6 as the value of our x. And let's rewrite again our original expression. So our problem here is we have x over 5 plus 1 over 4 is equals to x over 2. Okay, so let's substitute the value of x as 5 over 6. Therefore, it will give us 5 over 6, okay, over 5 plus 1 over 4, and that is equals to another value of x, which is 5 over 6, okay, over 2. Right, so we have this given expression. Now, I'm not sure if you're familiar with this one, but this is actually called as complex fraction, right? So let's simplify this one. So if you want to simplify this given expression or um, fraction, um, I will give you the concept. So 5 over 6 over 5, again, the concept of fraction is division, right? For example, a over b is actually written as a divided by b. Okay? Therefore, if we have this given set of problem, that means this is actually equals to 5 a over 6 divided by 5, right? It is actually written in that way. Now, since the concept of multiplication and division is quite similar or connected, so when we are dividing a value, we are just multiplying it, okay? We are just applying the concept of multiplication, but this time we are reciprocating the value of our divisor. That means for this given problem, um, we need to reciprocate the value of 5, okay? So we need this the inverse of this one or reciprocal of this one. And again, we know that the concept of a whole number, we always have this denominator 1. Okay? So if you want to reciprocate this value, therefore it will give us 1 over 5. Okay? And next, after that, we need to change our operation. So from division, we will now proceed to multiplication. Next tip. Again, when we are multiplying a fraction, so that is just multiply the numerator to the numerators and denominators to the denominator. That means the value of this given problem or expression is 5 times 1. It will give us 5 all over 6 times 5. That is equals to 30. Okay? That means this given expression is actually equals to 5 over 30. Right? So let's rewrite this one. So we have 5 over 30. Okay? So this is equals to 5 over 30. So copy the plus over 1 fourth. Okay? And that is equals to another set of complex fraction. Okay, so let's simplify this one again. So again, this is actually written as 5 over 6 divided by 2. Okay, let's reciprocate the value of 2. So it will give us 1 half. And let's proceed to multiplication. Okay, so it will allow us to multiply the numerators and the denominators. So we have 5 times 1. We have 5 over 6 times 2. That is equals to 12. So that is equals to 5 over 12. Right. So let's simplify this given expression. Since we have 5 over 30 plus 1 fourth is equals to 5 over 12 again, for us to save time and effort, always reduce our fraction into its lowest term. That means if we have this 5 over 30, so we are actually allowed to simplify this one by dividing both sides or numerators and denominator to 5. Okay? Therefore, 5 over 30 is actually equals to 1 over 6. Okay? The reduced form of 5 over 30 is 1 over 6. Okay? So let's continue. That means it will give us 1 over 6 plus 1 fourth is equals to 5 over 12. And let's double check this one. Is 1 over 6 plus 1 fourth equals to 5 over 12? Alright, so let's simplify. Again, for this given term, we are actually dealing with this addition of the similar fraction. Again, if we have the similar fraction, that means our denominator is not similar or not the same. So to solve this, we need to identify our LCD. So I think for this given problem, our LCD 6 and 4 is a factor of 12, right? So just simplify this. Just divide this 12, our LCD, to our first denominator. So 6 divided by 12, the answer is 2. And multiply the answer to its corresponding numerator. So 12 divided by 6, the answer is 2. And 2 times 1 is 2. So we have 2. And do the same thing to the another set of denominators. So 12 divided by 4, the answer is 3. And multiply it to its corresponding numerator. So 3 times 1, that is 3. So 2 plus 3. Right? And I will erase this one. So let's simplify. So we have this is equals to 5 over 12. Right? So let's add. So 2 plus 3, that is equals to 5. And copy its corresponding denominator, which is 12. Therefore, 5 over 12 is equals to 5 over 12. That means since this statement is true, it satisfies our equation. That means the value of our x here is a correct solution. Okay, so that is our example number 1. Now let's try to answer another set of problem. So for our example number 2, let's say we have this. Let's say we have 1/4. Okay, let's say that is equals to 3 over x minus 1/2. All right, this time we have this set of denominators with variable. Okay, so again, same procedure. So let's identify our LCD and let's eliminate all of our rational expressions. So for this given problem, we have this LCD as, I think that is 4x. Okay, so again, try to observe all of the values of our denominator. We have 4, we have x, and we have 2. Right, so we know that the value of 4 is divisible by 2. Okay, but this time we have this participation of a variable. Okay, that means we need to include variable to our LCD. So that's the reason why we have 4x. Okay, so let's multiply 4x each term, okay, and each side of our equation. So it will give us 4x times 1 over 4 is equals to 3 over x minus 1/2. Okay, so we will do the same thing sa kabilang side. Alright, now let's apply the distributive property of multiplication. So let's distribute the value of 4x each term. So it will give us 4x times 1, that is equals to 4x, and copy its corresponding denominator. Right, so that is equals to the right hand side. We have 4x times 3, that is equals to 12x over x. Okay, and we have 4x times negative 1, which is equals to negative 4x over 2. Now let's simplify this to eliminate our denominators. Okay, so this is actually will give us cancel out 4, so that is equals to x is equals to cancel out the value of our denominator again, or variables again. So cancel out variable x, therefore that is equals to 12. Okay, and 4x divided by 2 is actually equals to negative 2x. Okay, so we have x equals to 12 minus 2x. Again, let's isolate the value of x. Okay, so I think the practical way here is to add 2x both sides. Okay, so by adding 2x both sides, it looks like we move the value of 2x, okay, from the right hand side to the left hand side. So that means it will give us x plus 2x is equals to 12. Okay, so simplify or add this x plus 2x, it will give us 3x is equals to 12. Okay, divide both sides by 3, cancel out 3, therefore the value of x is 12 divided by 3, which is equals to 4. And that is our final answer. Right? So let's try to double check if our solution is a real solution or not. So let's do some checking. So for our checking, we will use the value of 4 as our x. Okay, so again, this is x is equals to 4, and let's use our original expression again. So our original expression or problem here is we have 1 over 4 is equals to 3 over x minus 1/2. Okay, now by applying the concept of substitution or law of substitution, it will give us 1 over 4 is equals to 3, and we have this x as 4, right, minus 1/2. Okay, so let's simplify. So we have this 3/4 minus 1/2 again. That is a similar fraction, so identify our LCD. So we have 4, and 4 divided by 4 is 1. 1 times 3 is 3. Okay, next, do the same thing to the next or to other fractions. So 4 divided by 2, that is equals to 2, and 2 times negative 1, that is negative 2, right? So that is equals to 1/4 again. So let's simplify this right hand side. Therefore, it will give us 1/4 is equals to 3 minus 2 is equals to 1 over 4. So obviously, 1/4 is equals to 1/4. This is a true statement. That means since that value, this 4 satisfies our rational expression or equation, that means this one is our real solution. Alright, so that is our example number 2. Okay, so let's try to answer another set of problem, and let's explore what are the possible questions, okay, or scenarios, okay, for this given topic, which is rational equations. Let's say we have this given problem, okay. For problem number 3, let's say we have x plus 1, alright, so that is equals to, or all over 2x is equals to 10. Okay, so let's try to solve this. Again, I encourage you to pause this video and try to answer this problem on your own. Alright, so let's try to double check your answers. Okay, so again, for this given problem, I think the value of our LCD here is obviously 2x, okay? Because we have this new denominator for 10 as 1. So obviously our um LCD here is 2x, okay? Since the value for our LCD is 2x, therefore, let's multiply 2x to our expression. So therefore, it will give us x plus 1 all over 2x is equals to 10 times 2x again. So let's substitute or distribute the value of our LCD. So therefore, it will allow us to cancel out this one. Okay, so cancel. So it will give us x plus 1 and distribute this 2x to 10. Okay, so that is 20x. That is equals to 20x. Okay, so again, our next step here is to isolate the value of x. Okay, so therefore, I think we need to subtract x both sides, okay, to isolate the values of x. Therefore, it will give us 1 is equals to 20x minus x. So let's simplify this. 20 minus x is actually equals to 19x, right? So divide both sides to 19, cancel out 19. Therefore, the answer for this given problem is x is equals to 1 over 19. Right? So that is our final answer. Okay? So next, let's proceed to our example number 4. And again, I encourage you to try to answer this given problem on your own. And we will double check your answer. Okay? So for problem number 4, let's say we have x plus 1. Sorry, let's say x plus 6. Okay? All over x minus 1. Let's say that is equals to 7 all over x minus 1. Okay. Now, let's try to double check your answers. Now, for our LCD, obviously, we had this same denominator. So, we will use x minus 1 as our denominator. Alright? So, let's multiply x minus 1 to our expression, and let's eliminate our denominators. So, it will give us x minus 1, okay, times x plus 6 all over x minus 1 is equals to 7 all over x minus 1. So we will multiply the right hand side to x minus 1 again. Okay, so let's distribute this again. We need to cancel out our denominators or and LCD. So it will give us x plus 6, and that is equals to, so 7 times x minus 1 again. So we need to cancel out our denominators again. So it will give us 7. So obviously we have x plus 6 equal to 7. Let's subtract 6 both sides to isolate the value of x, or if you want to move this 6, okay, with use of transposition, if that is your technique, it's up to you. But again, our goal here is to solve for the value of x. Therefore, it will give us x is equal to 7 minus 6, or x is equals to 1. Alright? Again, the value of x is equals to 1. Let's try to double check this solution. Again, this part will help you to appreciate the concept of checking. Okay? Now, as you observe your students, if you want to double check our answer, okay, with the use of checking, so let's conduct some checking. Since our value of x here is positive 1, and we have this given expression, x plus 6 over x minus 1, so this one will happen. So we have x plus 6 over x minus 1 is equal to 7 over x minus 1. So obviously, dear students, if we substitute the value of x as 1 to our given expression, so it will give us 1 plus 6 all over 1 minus 1, that is equals to 7 over 1 minus 1, right? So by simplifying this, it will give us 1 plus 6, that is 7, all over 1 minus 1, that is 0. Okay, and that is equals to 7 all over 1 minus 1 again, that is 0. So yes, obviously this is equal, but the problem here is the given expression is actually undefined, right? Since that value of x makes our function or expression undefined, that means that this x is not a solution. Okay? Therefore, the answer for this given problem is no solution. Right? So that is the concept of checking. Again, what is the value of x? So according to our solution, we have this x as 1, right? So that 1 is actually called as an extraneous solution. Okay? So again, it is called as extraneous solution. So we have extraneous solution. So again, extraneous solutions, it is just a solution or apparent solution that does not solve its equation. So usually it makes our equation undefined. Alright? So that is the concept of checking. Okay? So next, let's try to answer another set of problem again. So example number 5. So again, let's just try to solve this on your own and let's double check your answers. Okay? So let's say we have this. Let's say we have x plus 3 all over x minus 4. Let's say that is equals to x minus 5 all over x plus 4. Okay? So another scenario there, students, or another case wherein we have this set of denominator. It looks like the same variables and same numbers but different in sign. Okay? Again, to solve this one, our first task is to identify our LCD. Okay? Because that LCD will allow us to eliminate our denominators. Since we have this set of denominators x minus 4 and x plus 4, again, our technique is to multiply or think of a value that will make this two denominator a factor. So obviously, dear students, if you multiply this set of values, our LCD for this given problem is the denominators itself. Okay, their product. Alright? So if we have this given problem again, so try to observe our denominator. So if we have this set of expression wherein we're not allowed to produce another function or another expression, so just use the product of those denominators. Okay, so that's the reason why we have x minus 4 times x plus 4 as our LCD. So let's try to multiply our LCD to our expression. Therefore, it will give us x minus 4, okay, times x plus 4 times, we have our expression x plus 3 all over x minus 4, that is equals to x minus 5 all over x plus 4. Okay? And multiply it again to x minus 4 times x plus 4. Alright? And let's distribute the values of our LCD. So again, multiply this. So since we have this common factor, we have x minus 4 and another x minus 4. So it will allow us to multiply x plus 4 to x plus 3. Okay? So that is our technique. Okay? So just eliminate the common factors and multiply the remaining values. So the remaining values here is x plus 3 times this. Okay, we have x plus 4. Next, do the same thing to the right hand side of our equation. So multiply this, and again we have this common factor which is x plus 4 and another x plus 4. Therefore, just multiply x minus 5 to our remaining LCD, which is x minus 4. So let's multiply, therefore it will give us that is equals to x minus 5 times x minus 4. Okay? So it will give us this given set of expression. Now, to solve this one, just apply FOIL method. Alright? So it looks like we need to multiply two set of binomials to another set of binomial. So just apply FOIL method. Okay? Let's multiply this set of binomials. So we have this first, so x times x. The answer is x squared. Right? So x times 4, that is 4x. Next is 3 times x. Okay, that is 3x. And we have this 3 times 4, which is equals to 12. So plus 12. Okay, so that is equals to the right hand side. So we have x times x, that is another x squared. Okay, we have x times negative 4, that is minus 4x. Also have negative 5 times x, we have minus 5x. And for our last term, we have negative 5 times negative 4, which is a positive number 20. Okay, so let's combine those like terms or similar terms for this given problem and let's simplify, right? So therefore, it will give us, we have this similar term, 4x and 3x. And for the right hand side, we have negative 4x and negative 5x. So let's simplify those terms. Okay, therefore, it will give us this. So we have x squared, so 4x plus 3x, it will give us 7x. So plus 7x plus 12, and that is equals to x squared again. Negative 4x minus 5x, that is equals to negative 9x. And copy the remaining plus 20. Okay, since our goal is to solve for the value of x, we need to isolate the value of x again, right? So let's isolate the values of x. Let's move the values of x squared, okay, and 9x, right? And let's move the value of our constant here, right? So therefore, just combine all of the like terms here for this given procedure. So it's up to you if you want to apply APE or transposition. But again, our goal here is to isolate the values of x. So therefore, it will give us x squared minus x squared, right? So we have plus 7x, okay, plus 9x. And that is equals, so we have this remaining value as 20. And we will move 12, so minus 12. Okay, so let's simplify the set of values. So x squared minus x squared, that is cancelled out. We have 0. And we have 7x plus 9x, that is 16x, is equals to 20 minus 12, which is equals to 8. Alright? So, again, simplify this by dividing both sides to 16. So, cancel out 16. Therefore, the value of x for this given problem is 8 over 16, or simply 1 half. And that is the answer for this given problem. We have 1 half, or 8 over 16. Alright? So that is for our example number 5. Okay? So for our last example, so before we proceed to level 3 or difficulty, we will solve for another set of problems for the next video. Okay? Wherein I will give some set of problems wherein it requires some factoring to our denominators. Alright? So but before that, let's try to answer our last example for this video. So let's say we have x plus 6 all over x minus 2, and that is equals to 2x plus 3 or minus 3. Let's see, 2x minus 3 all over x plus 1. Okay, so again, same procedure, dear students, since we have this set of denominators. So let's use our LCD. Okay, let's use both of those denominators, the product of those denominators. So we have x minus 2 times x plus 1 as our LCD. Alright, so let's multiply. Again, it will give us x minus 2 times x plus 1 times, we have this expression, we have x plus 6 all over x minus 2, and that is equals to 2x minus 3 all over x plus 1. Okay, and multiply again to our LCDs, which is x minus 2 times x plus. Alright, so we have x plus 1. Okay, so let's apply the distributive property of multiplication for this one. So let's distribute this. Again, we have this common factor. We have x minus 2, cancel out x minus 2, and multiply our numerator to the remaining LCD, which is x plus 1. So it will give us x plus 6 times x plus 1. Okay, and that is equals to, distribute again. So we have this common factor, which is x plus 1, cancel out, and multiply our numerator, which is 2x minus 3, to our remaining LCD, which is x minus 2. Right? So let's simplify this again. Solve this with use of FOIL method, and let's combine like terms. Therefore, this is x times x squared. Okay, so I will do this again, same procedure. So 6 times x, we have 6x plus x times 1, x and 6 times 1, that is plus 6. Okay, so just apply FOIL method for this one. So 2x times x, we have 2x squared. Okay, 2x times negative 2, that is negative 4x. Negative 3 times x is negative 3x, and negative 3 times negative 2 is positive 6. Alright, so let's combine the like terms here. So we have 6x and negative 4x as our like terms or common terms. So it will give us x squared plus 7x plus 6. And that is equals to 2x squared. Okay, and negative 4 minus 3 is negative 7x. Copy the remaining plus 6. Right, so let's combine the like terms or isolate the values of x for this given problem. Okay, if you want to solve this, therefore it will give us 2x squared. Okay, I will move this value, so minus x squared. Right, so I will write the remaining 7x here and move um the another 7x. Okay, so we have minus 7x. So we have this remaining plus 6, and I want to move this another 6. Okay, so minus 6. Therefore, we will equate this to 0. Why? Because according to this given problem, it looks like it will give us a rational or a quadratic equation. Okay, so let's double check. So let's simplify this. 2x squared minus x squared. 2 minus 1 is 1, so we have x squared. Negative 7x minus 7x. The answer is negative 14x. Okay, and 6 minus 6, and that is equal to 0. So we need to cancel this one. Therefore, we have this set of expression which is an example of our quadratic, okay, equation. So to solve for the value of x, just factor out this one. Okay, it's up to you, dear students. If you want to use quadratic formula, okay, completing the square, extracting the root. Okay, but I think um it will allow us to solve for the values of x with use of factoring. Okay, so for the factor of this one, it will give us x. Okay, so we have 0 as our constant. Therefore, we have let's try to use 14 and 0. Okay, let's try to double check if we have this correct factor. So again, if you want to factor something or an expression, just think of two set of values wherein their product will serve as your constant. Okay, that is your constant, which is to our problem we have 0, and then their sum will serve as our midterm. Right, so let's double check. So negative 14 times 0, the answer is 0, so that is correct. So let's add naman. So negative 14 plus 0, the answer is negative 14x. So very good. So we have this correct set of factors. Since we have this set of factor again, just construct the table and let's solve for the values of x. Therefore, x minus 14, if that is equal to 0, therefore the values of x sub 1, or the value of our first x, is positive 14. Okay, and if we have x plus 0 is equal to 0, obviously the value of our second solution is equals to 0. So we have this set of solution for this given problem. Alright, so again, dear students, that is the entire concept of solving rational equations with different problems. So thank you so much, everyone, and God bless.